Hello everyone, this is Vinay here from Learn Coding with Vinay. In this video, we are going to discuss about a mistake that usually beginners do when they are designing their database tables, right? And the mistake is storing derived values into the database table directly. Now, what is derived values or derived data? Right? A derived value and derived data are actually data that can be retrieved from an existing data, right? Now if we are storing derived data into our database table directly, then it might result in redundant data, and in longer run it might also result in performance and storage optimization issue. So let's try to understand what is derived data and what is redundant data in terms of SQL table, right? So take a look at this table. We are creating an employee table. I have just given name as bad design. Ideally it should, the name of the table should be employee only, right? But here we are taking a bad database design example, that's why, right? So we are creating a table employee which has id, first name, last name, full name. Right now full name over here is a redundant column, redundant data, because we can determine full name based on the first name and last name columns, right? Now let's move ahead. Now if we are storing a data, if we are storing birth date into a database table, then we don't need to store age, because if we know the birth date, then at any moment of time we can calculate the age. So I have created this table without these redundant columns, and let's take a look at it. And I also put down some data. So here we have employee table with some data and with no redundant data in it, right? So but let's say we want those data in that manner. For example, we want full name, and then what we can do, we can always use some sort of expression. Here we have used string concatenation, and we have calculated age using birthday column, and using date difference inbuilt SQL function, right? So if I go ahead and run this, so we can still have the full name as our data, right? But the difference over here is we are not storing the full name as part of the table itself, right? We are calculating it at runtime. Let's take another example. Let's consider an e-commerce example where customer places the order, and usually there will be two tables: order header and order item. Order header will have details about who order what, basically customer id, order date and time, order number. And in the order item, there will be list of order items, their quantity and unit price and everything, right? So considering that, I have keep the table design a little short, or short and sweet. So let's take a look at it. So we have id, we have order id, we have product name, quantity, unit price, and we have total price. Now we don't need to store this total price as a column, because we can calculate it using quantity and unit price, right? So I have created this table also without this total price column. So let's take a look at this. So here is the table where we have id, order id, product name, quantity and unit price. And still if we want to calculate the total price in some or the other query or some of the other screen, then this is how we can do. We can use the expression as a dedicated column in our select list. If I go ahead and fire this, then we will have the total price. So we don't need to store that data, we can always calculate it at runtime. Now why this is a better approach? Because let's consider, say, for any reason unit price is getting changed, right, for a product, then we will have to make sure that this total price is getting updated also, right? Consider above full name example. And if some employee's name is getting changed, usually a male employee's name does not get changed, but changing a name of a female employee after the marriage is very very common scenario, right? So if we are updating the name of an employee, either be it either first name or last name, if we have taken the full name as a part of table column itself, then we will have to make sure that while updating this one of these two, we are also updating this, right? So this results in actually updation issue, and data might go in data might go out of sync, right? Because if we forget to update this full name, then it might create problem, right? Again with these example, if we forget to update the total, then it may result in loss to the e-commerce company, right? So that is one point, that data updation is very critical if we are if we are using the derived columns, right? And how it can harm us, right? So it is always better not to store it and have a dedicated query that runtime calculates it, right? Now what if we want, for performance issue or for a quick turnaround, we want derived values to be there in database table itself, right? And which does not result in updation issue. So we have two options over here. We can store that column data as a derived column, and we have two options in derived column, non-persisted and persisted. So what are those? So let me take a look at our employee table. We have four columns. Let me add this one more column, which is full name, which will be first name plus space plus last name. So I'm altering the table using this command. If I go ahead and run this, and so there is a column getting updated, full name. Now this is a derived column, and this derived column is non-persisted derived column example. Now what is non-persisted means? This data is not stored as a part of database table. They are just calculated runtime, right? Now let's take a look at the next example. Let me drop this full name column. Now this is an example of storing persisted derived column. So over here, let me run this, and let me run this query. So over here, when we use the persisted option with derived column, right, remember it stores data within the table itself, right? So again, this results in redundancy. So persisted column results in redundancy because here we are storing first name and last name separately, and full name again, same amount of data, right? Then when should we use this, right? So if you have very less amount of data, you are dealing with some hundred or some thousand rows, then non-persisted column will be a better option, right? If you are again, if you have again moderate data and you want the performance to be faster, basically query retrieval to be improved, so in that case you will have to use persisted column because the columns physically exist and we can create index on it for performance here, while with the non-persisted column we cannot create index on that column, right? So if you need performance while retrieving the data, go for persisted column option. So but again, they have their own advantage and disadvantage. One is coming with very simple approach, and it does not occupy storage memory, but the other one comes with a approach that it stores the data, it occupies storage, but since we can create index, so we can make the retrieval of data faster, right? So is there another way which can actually deal with both of these? There shouldn't be a performance issue and there shouldn't be a data storage issue as well. Then yes, there is an option. We can create actually an index view, right? And we can create index in whatever column we want. For example, here I have created an index view. If I run this query, I hope there, yeah, it is already there. So if I go ahead and run this, so I have order ID, total order, and count of records, count of item in it, right? So now based on our requirement, we can create index on any of these column, right? And these are not stored anywhere. They don't occupy storage, right? They are calculated runtime only, but we can still create index on a view. So retrieval also be faster and storage space also be saved, right? Now with this, I hope this will give you a good idea about derived columns, derived data, and what to do and what not to do with derived values, right? So the thumb rule is quite simple. Don't store just derived data into the database table. Have some other way, like derived column with persisted column or not non-persisted column, or even the better way would be create an index view and create an index on your desired column, which is probably used in many your where conditions in your application, right? So that way we can tackle the both. Now what are the other scenarios where we will be seeing these derived data issues frequently? And so there are certain domains where we will be working with measurement units. For example, let me open this excel sheet, right? Let's say we are working on a healthcare data, and we are developing a software which is for a clinic, and if we go to the doctor, doctor will check this patient, and based on the observation, doctor will prescribe the medicine. Let's say medicine contains a syrup, right? So the dosage of that syrup will always be in ml, right? Right, so storing data in ml will make sense over here, right? Another example of a patient's weight, there we will be storing data in kilograms, right? Now why we are discussing this, because one common mistake people do, that storing this measurement data with the least unit in, for example length, height or width, they'll go with millimeter. For any liquid they'll go with milliliter, right? For any other things, any other, the least amount of uh, unit the people will use. But that should not be the case. The benchmark should not be always the least unit. The benchmark should be what is commonly used, what is frequently used, or what is popularly used unit of measurement in your domain, right? So we saw that example. If you are talking about medicine dosage, it will be in ml. If we are talking about patient's weight, it will be in kilograms, not in grams, right? Then again, if we are taking some tablet, then the dosage of it might be of milligram only, right? So here storing again the data in grams on kilogram will make no sense, right? Next example, if we are working on oil and gas or oil and energy industry, right? Over there we will be storing the data of oil in barrels. Now one barrel is approximately 159 liters. So this data, storing in milliliters will not probably make sense, right? Because it will be huge amount of data every time we are storing, right? So storing barrels will make sense. However, if we are working on an automobile industry, right, and if we are working on let's say either two wheelers or four wheelers, and we are storing fuel tank capacity somewhere, right? So most of the time, for two wheelers it will be around 10 to 14 or 16 liters, and for cars or four wheelers it will be 20 plus liters. So storing fuel capacity data in liter makes sense over here, not in ml, right? Not in milliliters. Right. Now let's take one more example, construction or maybe real estate. Right. So if we go somewhere, we want to buy home, or we want to buy land where we can build the home. Right. So that land data we will be discussing in square feet. Right. Here we will not discuss centimeter or millimeters. Right. Again, if we are talking about some a big agriculture land, or maybe some pond where we want to do prawns farming or fish farming, right? So there we will probably talk about acre or hectares, right? There we should not talk about square feet or even on centimeters, right? So depending on what is commonly used in that particular domain, we should use that measurement, we should use that unit of measurement over there, right? So I hope you learned something new in this video, and subscribe to my channel, which is Learn Coding with Vinay hyphen SQL for developers, right? And thanks for watching this video. See you in the next video. Till then, bye bye.